Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Now, if you want more uh, discussion on the concepts of this topic here, you just proceed to my other playlist on statics, your one-stop channel or course. You can find there the concepts on cross product and scalar type of product so that you can easily follow the solutions here. So determine the angle P and the unit normal vector having a positive x component for triangle ABC. So to solve for this angle, we need to obtain the dot product of BC, unit vector of BC and unit vector of BA, because the dot product is the magnitude of the first, magnitude of the second, times cosine of the angle between them. And that product is the sum of the product of corresponding components. So let's derive the unit vector of BC. That's lambda BC, lambda BA. So lambda BC, it is directed leftward and upward only. So leftward, negative 8j, upward, positive 6k. So lambda BC is negative 8j over 6k over square root of 8 square plus 6 square. Simplifying, lambda BC is negative 0.8j plus 0.6k. Lambda BA is leftward, forward. So lambda BA is negative 8j, positive 10i. 10i minus 8j over square root of 10 square plus 8 square. So lambda BA is 10i minus 8j over square root of 164. Then obtain the dot product. Lambda BC dot lambda BA. Magnitude of BC is 1. Magnitude of BA 1 also, times the cosine of the angle between them, which is P. Then we have negative 0.8j plus 0.6k times, or that 10i minus 8j over square root of 164 equals cosine of theta, cosine of P. Since that product has a value only if we dot corresponding components, so negative 0.8 times negative 0.8 times negative 8 is 6.4 over 164 equals cosine of B. So from there we can solve B 60.02 degrees. Then the unit normal vector having a positive x component for triangle ABC. So since this point has positive x component, so we cross AB with AC as shown. It defines this vector here perpendicular to AB and AC. So AB is backward 10, so negative 10i, rightward positive 8, so 8j. So negative 10i plus 8j, that's AB. AC is backward 10, so negative 10i, upward 6, so plus 6k. So negative 10i plus 6k, that's AC. Then obtain the cross product. So components of AB, components of AC, IJK, unit vectors, copy the first two column elements. Then expand. So 8 times 6, 48i minus 0. So that's AB cross AC. And after we get that, we derive the normal vector, which is AB cross AC divided by the magnitude of this vector, resulting vector, which is here. So 48i then for J0 minus negative 60, so 60J, positive 60J. Then for K0 minus negative 80, so positive 80K. So that's AB cross AC. The unit vector is obtained by dividing this by the magnitude. So the normal vector, unit vector is 48I plus 60J plus 80K over square root of 48 square plus 60 square plus 80 square. So the normal unit vector is 0.4279I plus 0.5409J plus 0.7212K. For your part, determine the angle theta and the unit normal vector having a positive Z component. So it's at C here. So this is theta. Then I want you to solve for theta and show that it is 47.96 degrees. And the unit vector with positive Z component is equal to 0.5103I plus 0.1276J plus 0.8505K. So that's it for your part. Example 63. Forces F1 and F2 are both applied at point A. The force F1 is given by 500I plus 400J plus ZK newtons is to form a 60-degree angle with a force F2 quantity negative 200I plus 100J plus 300K newtons. So determine the value of Z, the unit vector normal to the plane formed by F1 and F2. So that unit vector is after we cross F1 and F2, then divide it by the magnitude of that resulting vector. So first, the angle formed between the two vectors is 60. We apply that product, F1 dot F2 or F2 dot F1, that's the same. So it is magnitude of F1, magnitude of F2, cosine of the angle between them, which I call theta. F1 is given by this times F2, so 500 times negative 200 in the expansion plus 400 times 100 plus Z times 300 or 300Z equals magnitude of F1 square root of 500 square plus 400 square plus Z square. Magnitude of F2 square root of 200 square plus 100 square plus 300 square times cosine of 60 degrees. Simplifying the left, it is negative 60,000 plus 300Z, then square root of 410,000 plus Z squared, this one. Then this entire value, this magnitude is 187. This value times cosine 60 is 187.083. Dividing everything by 187.083. So negative 320.713 plus 1.6036Z equals square root of 410,000 plus Z square. Square everything. So the square of 320.713 is 102,857. Then the product times 2 is negative 1028.59Z. The square of 1.6036Z is 2.5715Z square. Then the square of the right side, we just copy, remove the radical. Combining like terms, simplifying 1.5715Z square minus 1028.59Z minus 307,143 equals 0. So using your calculator quadratic equation, there are two values of Z. One is positive 877.3 newtons and the other is negative 222.8. So for positive Z first, let's have the cross product A F1 cross F2 equals sub 1 components of F1 with Z equals 877.3 components of F2, then unit vectors. Copy the elements of the first two columns, then expand 400 times 300I minus 100 times 877.3 is equal to 32270I. Then 877.3 times negative 200J then minus 300 times 500. Check if it is negative 3 to 5,460 J. Then for K, 500 times 100, then minus negative 200 times 400, so plus 500 times 100 plus 200 times 400. It is 130,000 K. So the unit normal vector, we simply divide this by the magnitude of that vector. So lambda n1 is 32270I minus 325,460J plus 130,000K over square root of 32270 square plus 325,460 square plus 130,000 square. So it is 0.09169I minus 0.9247J plus 0.3694K. For the second value, when Z is negative 2 to 2.8, so F1 cross F2 sub 2 is 500, 400, negative 2 to 2.8, negative 200, 100, 300, then IJK, quantity 500, 400, negative 200, 100, IJ. So using your calculator, 400 times 300I, then plus, because this is negative, plus 100 times 2 to 2.8. Show that it is equal to 142 to 80I. Then for J, negative 2 to 8, negative 2 to 2.8 times negative 200 minus 300 times 500. So check if it is negative 105,440. Then for K, 500 times 100, then minus in that direction since this is negative, so plus 500 times 100 plus 200 times 400, 130,000 K. So the unit normal vector 2 is this vector divided by the magnitude square root of 142 to 80 square plus 105 for 40 square plus 130,000 square. So the unit normal vector when Z is negative 2 to 2.8 is equal to 0.6477I minus 0.4800J plus 0.5918K. So that's it for this problem. Then for your part, it is desired to pass a plane through point A whose unit normal vector is given by this. So determine the values of YB and Z sub Z, thus locating where the plane intersects the corresponding coordinate axis. And this is the figure. And show that YB is 1 and Z sub Z is negative 3 meters. Problem 64. Line AB is perpendicular to line AC. Determine the value of XB and a unit vector having a positive X component. So here is the given figure. So and the angle at A is 90 degrees. So this gives us the idea that if we dot AC with AB, the dot product is 0 because the angle is 90 degrees. So it is AC, AB, magnitude of AC, magnitude of AB, cosine of 90. Cosine 90 is 0. So AB is going backward, negative 0.3I, leftward, negative 0.6J, upward, 0.1K as a vector. So AC is negative 0.3I, negative 0.6J, positive 0.1K. While AB is XB minus 0.3I, then negative 0.6J going down negative 0.4K. So XB minus 0.3I minus 0.6J minus 0.4K. So obtaining the dot product, AB dot AC is equal to 0. So negative 0.3 times quantity XB minus 0.3 plus negative 0.6 times negative 0.6 plus 0.1 times negative 0.4 equals 0. From here, only xb is the unknown. We can now solve xb 41 over 30 or 1.367 meters. For the unit vector, normal vector having a positive x component, so that's point B. So we obtain the cross product of BA with AC, define it first, then it is a vector perpendicular to the planes of BA and BC. Then the unit vector is obtained by dividing that by the magnitude of the resulting vector. So BA is going backward, XB, which is negative of XB minus 0.3. So just this distance here. So negative of 41 over 30 minus 0.3. XB is 41 over 30. Going to the right, 0.6, so positive 0.6 J. Then upward 0.4, positive 0.4 K. Then you can simplify that if you want. BC, on the other hand, is going backward, negative 41 over 30 I, upward 500 mm or 0.5 meter K. So obtain the cross product components of BA, negative 16 over 15. So 41 over 30 minus 0.3 is 16 over 15, then negative, so negative 16 over 15, 0.6, 0.4, negative 41 over 30, 0, 0.5. Unit vectors, copy the elements of the first two columns. So for I, 0.6 times 0.5 I minus 0, so 0.3 I, BA cross BC. Then for J, 0.4 times negative 41 over 30, minus 0.5 times negative 16 over 15. So the net value is negative 1 over 75J. Then for K, 0, then minus negative 41 over 30 times 0.6, so that's plus 0.82K. The unit normal vector, therefore, is copy the vector divided by the magnitude. And the magnitude is square root of 0.3 square plus 1 over 75 square plus 0.82 square. So the unit normal vector is equal to 0.3435I minus 0.01527J plus 0.9390K. Then for your part, line CA forms 60 degrees with line CB. Determine the positive value of YA. Refer to this figure. Replace 600 by YA. It is now an unknown. And a unit vector having positive Z component. Then replace XB by 1 meter. So that's your problem. And I want you to show that these are the answers. YA 0.5404. And the normal unit vector is given by that. So that's it.